Hello, my name is Shariful Islam. I'm a National Heart Foundation Senior Research Fellow at Deakin University. When the Berlin Wall fell, I was in Saudi Arabia, studying in year 10, practicing coding and preparing for my medical school exam. When I was a child, I always wanted to become a doctor like my parents. I developed a great interest in computer science and learned coding to develop small programs at school. After my medical graduation, I realized that there is a great potential to apply information technologies to improve human health. I became fascinated with cardiovascular research and find ways to meet the unmet need of patients, especially developing innovative solutions for improving heart failure management. My research breaks the wall of heart failure. Globally, over 64 million people are living with heart failure, which is a chronic progressive condition with increasing prevalence. Heart failure is the leading cause of hospitalization among older people. Despite significant advances in treatment, 3 out of 4 heart failure patients are readmitted to hospital and 1/3 die within a year, mostly due to discontinuous and lack of post-acute care monitoring. Till now, there is no cure for heart failure, and monitoring of symptoms, medications, and healthy lifestyle are the foundation of management. Current approaches for supporting people with heart failure are fragmented and largely clinic or hospital-based. The persistently high readmission rates and mortality highlight the urgent need to improve existing support for people with heart failure beyond hospitals. Traditional and cardiac rehabilitation programs and recent trials using information technologies have shown promise in improving heart failure management. However, these programs have been limited due to lack of personalization, targeting a single risk factor, and lack of timely interventions. My innovative idea is to apply an intelligent smart home ecosystem that uses sensors and devices to capture participant data, applies artificial intelligence to learn health patterns and predict health worsening, and provide individualized digital support to improve health outcomes, thus reducing readmission and mortality in this priority population. My research has focused on developing new technology-supported models for people with heart failure. In an exciting collaboration with clinicians and information technology experts, I have developed a prototype smart home system that can collect data, analyze, and intervene. I have conducted a Delphi survey and an in-depth interviews with healthcare providers. The preliminary results suggest that healthcare providers consider these new technologies essential for people with heart failure and showed willingness to trial in their practice. Healthcare providers also agreed about the need for a predictive, preventive, and personal care program that will create a paradigm shift in heart failure management. Researchers in my team are exploring a diversity of other support approaches for heart failure management. For example, developing an AI-supported conversational agent to communicate, support, and prompt patient engagement, and using facial recognition technology to understand and intervene anxiety and mood disorders. Along with my postdoctoral research fellow, PhD students, and collaborators, I am looking at novel approaches to support people with heart failure to better manage their condition and improve health outcomes and quality of life. People with heart failure receive little support at home, leading to preventable complications and hospitalizations, causing significant impact on individuals and societies. My innovative work will support heart failure patients using real-time data and artificial intelligence to identify problems early and then intervene, which is unique. This individualized data will empower patients, support clinicians to make better treatment decisions, and progress towards a personalized digital medicine that can revolutionize healthcare. I will identify and validate digital biomarkers and algorithms for assessing and predicting heart failure worsening, which is unpredictable. The home-based physiological monitoring and detection of patients at risk of worsening will provide an early window for clinicians to diagnose and tailor treatments remotely, thereby avoiding future unplanned hospital admissions. If successful, this model could be linked with heart failure clinics in regional and remote areas where patients receive even less support. My mother, a family medicine specialist, thinks that my research will inform the next generation care model for heart failure patients and potentially can be applied for other chronic conditions in Australia and internationally. The development of an artificial intelligence supported patient care program is a complex task, largely because the underlying pathophysiology of heart failure worsening is very incompletely understood. I am working to address this problem, but what keeps me lying awake at night is how can we come up with innovative ways to detect early physiological changes and provide timely intervention to prevent hospitalization and adverse outcome in this priority group of patients.